My name is Keith Kaplan. I host this program called Behind the Code. We sit down with one person at a time and interview them for about an hour, talk about what they've accomplished at Microsoft and how, and luckily we talk to people, some who've been at this for a while, so they've had a chance to maybe even regret some things and change their minds about some decisions of the past. We have Tony here live today, and because this is an internal-only audience, he has specifically requested rude questions, because he can tell you everything that he regrets, or everything he thinks other people should regret too. So ask him lots of good questions, please, because he's free to answer them today. And that's about it. Let's roll the show.
Good. So it's always more fun when, I don't have to be careful about what I say, Back in the old days, I was forever giving pitches to customers or ISVs or, PDC presentations, and of course you have to go along the party line. When I gave the talk to the MSR people about COM, it was a refreshing change. So, have at it. Yes?
Connected Applications Framework. The video was, just a little bit of touched on this subject. Can you give us a little bit of information on what it is, how it is different from COM, what problems it's trying to solve, and how it's going to be available for Microsoft in general for other products?
Okay. So first of all, it's built in managed code. So it's only if indirectly touching COM through the COM interop support that .NET has. The nature of the framework is there's a couple of major pieces. There's a data flow engine, which is a thing which manages a connected graph of transformations. And it does incremental evaluation, on-demand evaluation. It traces dependencies so that you can do incremental recalculation. So then layered on top of that, we have this declarative composition engine for saying, let me instantiate a whole bunch of UI pieces and connect them up to pieces of the data flow. And it cooperates with this recalc engine in order to rebuild UI as needed. So it can rebuild the calendar layout for the printing assistant. Or it can rebuild a menu bar when the menu definition changes, and all this sort of stuff. So between these two things, you get a declarative construction of data processing in the form of transformations and of UI construction for UI that lets you interact with that data. And we wrote a little language called ZAD, which was, the XML application description or something, to describe the rules by which a piece of data drives creation of a piece of UI and application structure. In terms of making it available, it's being used right now to build a set of tools for business analysts and IT professionals and so on. The current plan is not to expose this framework to anybody in that round of product releases, but to do so after that. We could potentially make it accessible to internal Microsoft people who wanted to use it. And it's something, I'm talking to a number of different groups about places that we might be able to exploit it if they're interested. But we don't have any formal plans to do that. We don't have resources to go put out an SDK with all the documentation and samples that you would need and so on. So it's very much sort of an informal exploration at this point. If anyone is interested to find out more, I'm happy to spend time talking, informally about it and following up on ideas. Does that help?
Is it even available as a framework for Office 12 Live?
Well, internally we have builds and drops and a limited amount of how to install and get started kind of information. No one is at this point drawing on that and using it outside our team. I mean, I can point you to it if you want to play with it. So interestingly, one of the things I've just done most recently is kicked off an effort to package this framework up actually as an ActiveX control so that we can then put it in a web page and have the declarative description come downloaded from a web web server in principle and then run in the web page on the client. Because I think I'm seeing a number of scenarios where that would be valuable. And so I want to put together a proof of concept and start showing it to a number of people. Yeah.
For you personally, how will the feel of the company change when Bill goes off to work at the foundation?
I think it's changed so much that it'll be just sort of more of the same, just another change. I think there were changes when Steve took over as CEO. Even before that, there were changes every time we got a new president, which was sometimes more frequent than others. Mainly, the biggest effects that I've seen are effects of scale. I mean, the company is just so big, and things work so differently as a result. Necessarily so, I believe. We don't know how to do otherwise. I think those have the biggest effects. And when an organization gets big enough, a new phenomenon emerges, which is the middle management phenomenon. And for some guy in the middle of the chain, the decisions that are best for his personal situation, his career, whatever, his team, and the decision that's best for the company at large might not be the same. And there are consequences to letting that sort of phenomenon happen. So I'm very pleased that we're trying to sort of fix organizations where that has started to emerge and sort of turn back the clock in some sense to get away from that. And I'm glad we are trying to do that. Remains to be seen whether we can organize differently when we're as big as we are. But, it's the pointy-head boss phenomenon in Dilbert. And, I've heard people say, thank God we're not like that. And I'm saying, what are you kidding me? Of course we're like that. Don't you hear it about once a week, something like that? And it's just an emergent property of large organizations. It seems to be that way, and you have to really fight against it. So when Bill's already sort of getting more hands-off in terms of software architect role. He's still doing quite a lot of it, but over time that will sort of ramp down. One of the things I think that might change as a result of that is his obsession with code sharing and having sort of a unique implementation of any given thing, which is sort of what's been driving a lot of his what he's asked people to do over the years, and in particular me, because I was saying, yes, boss, I will try and do that. I think that will decrease because it was his particular passion, and I'm not seeing that other people have that so strongly. So I think we'll get less of that, which hopefully doesn't mean that we just give up on the whole idea, but it should take off some of the pressure for taking dependencies on things that are still in development and might not ship, which has caused us a lot of trouble over the years. I see heads nodding, so people have experience clearly with this. It's kind of an interesting thing. When I started the ComApps effort, we had done some analyses of projects that were, let's say, mixed successes or even outright failures, and saying what's been going on with these projects. And a major issue is this problem of dependencies. One that I recall that was in real trouble was there was an effort called Sterling, which was an attempt to sort of rebuild Access in a more component-based fashion. And they'd sort of divvied up the components among different development teams. So there was a sort of a forms team and a language team, and I forget what all the teams were. And they had created this situation where they had a cycle in the dependency graph. And the cycle was somewhat artificial in the sense that some team was responsible for a set of components which were not really coupled, but they were just developing them in that team. And the packaging of that set of components into one is what introduced the cycle, the apparent cycle. Well, the consequence of this was it took them like 2 weeks to do a build to integrate across these different teams. And by the time you've done the build and got it all to work and everything's up to date with each other, and you start finding bugs and you try and report bugs back, these other guys have done 2 weeks more work. And this is a non-terminating process. Okay. So even if the internet hadn't happened and they decided this was the wrong product anyway, that project was very likely headed for disaster because of not understanding how to manage dependencies. And there's a similar phenomenon. I don't know how many of you know about the Windows layering exercise that they're trying to go through. But that is an attempt after the fact to understand dependencies and partition the system and try to get towards being able to develop, a minimum Windows for embedded or other uses and, layered Windows and so on. And they're trying to retrofit it and running into the same issue that there are cycles in the dependency graph and what do you do about them and that sort of thing. And if you try to do it across product units or different organizations that have different ship dates, it's a nightmare. Yeah.
Did we pretty much give up on a componentization of the legacy products that we have?
I think I'm not seeing, so aside from the Windows layering exercise, I'm not aware of any major efforts to take significant code bases and re-engineer them in the componentized form. I'm not aware of any efforts like that. I mean, the few exceptions would be things like line services and page and table services that were extracted, the concepts and design were extracted out of Word, re-engineered, refitted back into Word and other products. But there's very few examples like that. I mean, even .NET, which is starting out with, a lot of the right basics for building components, the .NET framework itself is very heavily interdependent. You touch one piece of it, you get all of it. So it remains a kind of unsolved problem. There's one back there.
You talked about the relationship or the comparison between the software architect and the bricks and mortar architect. You mentioned aesthetics with respect to application look and feel and usability. How about how it relates to, for example, just the code itself, this desire for aesthetically good-looking code and the attention to detail that might have? And I know some parts of the company have rigorous obsessions with, for example, normal form, and other parts of the company just are very vague about what's expected.
So we're talking here about the aesthetics of code as an artifact, and I mean my instinct is to say that it is important. It's very hard to justify, because in the end of the day, does a paying customer see any benefit from that aesthetic? And you can argue indirect benefits about maintainability and so on. I think the bigger benefit really is if someone has a strong aesthetic about code, they've probably also got a strong aesthetic about design and the resulting user experience. Let me tell you a little story. A program manager who worked for me at one time asked me, how could it possibly be that an architectural consideration in a piece of software could cause this idiotic user interface behavior? And what this was that you fire up Outlook and you get, after a pause, you get a dialog that says, cannot connect to Exchange Server, and your options are retry and work offline. There is no cancel. And he asked the Outlook team why can't they put a cancel button on there? And the answer was it's an architectural limitation. And what that means is that down in MAPI somewhere there's an API that you call and it tries to connect, and if it can't, it has no way to return cancel. And that's an architectural design. And then somebody may not have thought about that, but if they'd had a broader view of how this stuff's all going to fit together and what's going to be the experience of using it, they might have said, oh, that's a bad idea. You know, so I think these things all relate to each other.
I find the relationship between the use of the overloading of the word architect across different industries kind of interesting. I've heard bricks and mortar architects complaining about other bricks and mortar architects that they don't know how the process of the construction of the building works. And I've heard code architects complaining about other architects saying they don't understand how the process of code creation works. I think the job title sometimes is thrown around a little loosely at Microsoft.
Oh, absolutely it is. Somebody did a trawl through the address book, picking out people whose title said architect and sort of doing some demographics, you know, and the range of jobs they were doing and ladder levels they were on and so on. It was all over the map. We're not at all consistent. A real building architect has one particular distinction, which is they're required to have a certain qualification and they have legal liability. And we should think about that. We should think about that. Sorry, you had one.
Oh, it might be a silly question. Knowing what you know about componentization in organizations like hierarchical software systems, have you ever thought about applying componentization to the hierarchy of a huge company like Microsoft?
Componentizing a company. Well, I mean, that's sort of what we try to do with the org structure. And, you know, we have feature teams and product units and, you know, and it's an attempt to say, let's contain some amount of communication within a smaller unit and have less frequent communication across the larger scope of units. And that's really what componentization in large part is about. So I think, you know, any attempt at constructing an organization structure that isn't just a sea of people shouting at each other is some form of componentization. You know, people in the past have tried things like matrix management, you know, which means you're responsible to two people who don't agree, and and you have twice as much reporting to do, you know. Yeah, I mean, I don't particularly have any bright ideas.
So supporting multiple interfaces would be disadvantageous.
Potentially. Potentially. Yes, I mean, if you have multiple obligations on you, you may find they're in conflict. So again, you know, that sort of speaks to the larger scale. Have we decomposed the problem in the right way in order to make sure that we don't have problems like that? Yes.
I was going back to it's a bit of an unsolved problem, referring, I guess, to programming in the large, which seems like it's sort of not really I mean, it's kind of an old problem. I don't know that there are any historical role models of successes, but there's lots of role models out there, like the mythical man month and OS 360 and telephone switches, 5ESS, and ABMs, I think, at one time were one of the world's largest programs. And my understanding here is that almost all of them have a sort of lifetime, and at some point they get so large that they aren't sustainable. And I'm wondering if there's some long-term thinking that at some point this too shall pass, and we need to have something for, you know, what to do after that happens. Or is that such a heretical thought that we couldn't even think about that?
Well, this is an important thing to think and talk about. You know, I've been aware of people saying for at least 10 years, possibly 15 years, that Office applications were going to soon reach the point where they wouldn't be able to innovate anymore. And, well, I guess we were wrong. Now, they may be constrained in how they can innovate, but boy, they keep on churning it out. I suspect it's more likely that what causes a product or a product family or a code base or something, what causes it to become stagnant is more an external change, an environmental change of some kind. example that's coming up might very well be multi-core. You know, we may say, you know, our code bases are simply not going to work in this new world of multi-core chips if it happens that way, and that it's time for something new. You know, it may be that that's what will cause it to change. So for, you know, OS 360 that, you know, is sort of running out of steam, well, the thing that really changes it is the microprocessor, potentially. You know, you shift to a new world and you compute in a different way. So I wouldn't claim any prescience on any of these things, but sort of getting back to the componentization question about, you know, have we given up on componentizing our existing code bases? And I think we probably have, and I think it's just a matter of expense. And, you know, if anything, people might try to do new things in a better way. You know, example, OneNote. Let's say OneNote's a new product, and maybe it can be done in a better way. Maybe it can learn some lessons about what not to do. And as a case in point, I went to find out about how they do their synchronization of OneNote data between you know, client and server, or between peer-to-peer and so on. They have a very nice design about how they do that. It's very well factored. You know, I was impressed. So I think teams can do new things in better ways, but I don't see anyone paying the expense of refactoring existing stuff just for the hell of it. You know, that's expense with not necessarily any return. I'm not sure if that responds to what you really wanted to know.
Well, it'd be useful to know that there were efforts like OneNote or so on, where if some world change happens like multi-core, that we weren't completely, you know, locked, chain and ball to something that might, you know, not be the future.
Yeah, I think, you know, the best we can do is try to build in more flexibility where we know how. But it's not always easy to predict what's the change that you're going to have to adapt to. And, you know, you might say, well, we know it's going to be multi-core, so we know we've got to have, you know, parallelism of some sort. What sort should it be? Can we start to build for that? Whatever bet you place there, you're taking a risk, because you may get it wrong. You may make an investment now that doesn't repay you later. So why did you burn that money? You know, it's tough. I have heard people, you know, who are now VPs, I have heard people say, if you try to predict things like that, you will be wrong a sufficient amount of the time. That means it's not that you've wasted that effort. So you're probably better off not trying, because even the ones where you did guess right aren't enough to pay for the ones where you got it wrong.
Would that same logic say you should never buy an index fund? Because you'd never bet all your money on the right answer?
I'm not sure it's a comparable situation. I mean, if you're building a product with a certain set of features for a market and you think you understand that, trying to invest some additional money in some potential future is the thing that they say is suspect. And, you know, any kind of investment is placing a bet on a potential future. So maybe the message would be you just don't invest in the market, because you can't be sure.
Very binary way of looking at things, in that as much as Microsoft has the resources to do small projects as well as big projects. Mm-hmm. And so, yeah, betting the farm on, we need to build a concurrency runtime because multi-core is coming and we need to understand distribution better, blah, blah, blah. Yeah, if you put a 400-person team on that, you might live to regret it. But if you put a 10-person team on it and it doesn't work out, well, then those 10 people learn something valuable. Microsoft seems to invest hugely in these big name projects that evaporate.
Well, we do make mistakes like that, or have done in the past. We do also have smaller teams doing those more investigative things. So there are teams looking at, you know, approaches to multi-core like transactional memories and all sorts of stuff. the CTOs have quite a staff of people doing very speculative things like that. Early work. Really, what I was talking about is much more in the space of what should a team like Office be doing in their code now, right? And that's where conservatism rules. Right? Yes.
What do you think about side-by-side? Do you think it really solves the DLL help problems, or how do you see the side-by-side evolution?
It solves the DLL help problem for installation of what you might call an application or multiple applications. If you want any kind of composition of applications together, like we did with Ole and COM, then it's antithetical to that, because where they ended up is within a particular silo, you can only have one version of any given class. Or actually it's assembly, but whatever, it boils down to class. So if I try to put two different components into the same space, but they were built against different versions of some underlying class, you're out of luck. And side-by-side says you basically have to run those things isolated from each other. But then there's no way to do any kind of integration between them, because no one's built Ole for .NET, right? And that problem remains. We still have that dilemma. So, if you wanted to have a nice third-party ecosystem market for WinForms controls, let's say, the problem arises of, well, side-by-side is an issue for those people. And, if a customer buys a new version of .NET and wants to use his old control, he's faced with a dilemma. He maybe has to go get a new version of the control if it exists, or wait for it to be produced, and so on. So that is a big unsolved problem with .NET and its side-by-side approach to versioning. If you stick with apps that don't integrate with each other except through file system and clipboard and well-defined things, then it works, and it does help. So I guess we're about out of time here. Thank you all for coming.